In this video, we are going to demonstrate song creation. The purpose of this video is to take our newly created song class and show what it can do.
Right, so if you went through the MusicEngine demonstration before we actually got into the drum game, you're going to see some things that are fairly similar. You're going to recognize a lot of what we're doing here. But the point is to take these classes that we've put into our drum game and show you how they can be used in a similar method to generate music.
Exactly. So let's jump in here and turn our attention to the game screen. So here in the screen game class, we will jump down and we need to establish exactly how we're going to store song information from the standpoint of a game. Now, if you remember back to the music demo, we had to store individual integer lists for every track. Here with the song and note setup, all we have to do is store a reference to a song. So here inside of the game, let's see, we'll jump in right before our input pressed method, and we'll make a field of type song, and we'll call the field song. Now to turn around and use this, let's put together a reset method. So let's take our game screen and we will override the method reset. So whenever the game screen is reset, we'll have it create and initialize a song. Now to gain the song instance, that's very simple. We can just take our song field and say that that equals a new instance of song. And that will give us a new and empty song. So the song itself will contain a list of notes internally, and that will be empty. So as soon as we have a song, in order to record information, we need to put together a series of notes. We need to add notes to the song. And that's as simple as jumping into song.notes and calling add. But in order to add enough songs to make an intelligible beat or rhythm, we have to add quite a few notes, and instead of spacing them by hand, we'll assemble them using a loop.
Okay.
So we'll set up a loop to walk tick by tick, and then every time it finds a tick of interest, drop a note at that tick. Now, in order to define what our interesting ticks are, we'll put together the tick values for a handful of notes. That way we can look at things in terms of notes as we put this pattern together. So we'll make a few local variables here inside of reset. We'll put together a variable called eighth note. And we'll set the eighth note's tick value to be equal to song.quarter note divided by 2. So half the length of a quarter note. And let me correct the spelling on eighth note. And then we should have that.
And pull out your extra H. There you go.
This one?
Mm-hmm.
There we go.
E-I-G-H-T, yeah. Well, I'm sorry, nope, it goes back. Silly me. I was thinking eighth note, not eighth note.
So all of this math and spelling, that's the
Yes.
real challenge.
Math we're fine with, it's spelling that kills us.
Alright, while we're declaring variables, let's directly copy the quarter note value, just so that everything looks the same as we're using these variables to place notes. So we'll make a variable called quarter note, and we'll say that that is simply equal to song.quarter note. And finally, let's also give ourselves a half note. So I'll have an integer value called half note. And we'll say that that is equal to song.quarter note times 2. Now, as we put the loop together, we need to decide exactly how many ticks we're going to loop over, how much time would we like to create. And to do that, we'll put that together in terms of actual measures. So in order to make this easy to read, we'll make another variable called measure count. And we'll begin by setting that to 1. So from the start, we'll only have a single measure. Then if we would like additional measures, we can simply add them without having to worry about individual tick values. Alright, with this set of variables, we should be ready to assemble our loop. So we'll make a for loop, and then tab twice to bring up the template. we will call the variable for our loop index tick. And we will loop over the overall number of ticks that we will have in total. Now, a single measure can be gathered by looking at song.ticks per measure. So just doing that would give us one measure.
Mm-hmm.
Now we could turn and multiply that by measure count, and then we could use that to give ourselves any number of measures. So jumping inside this loop, now we need to watch each iteration of the loop and note when the tick value happens to match a note that we're interested in.
Mm-hmm.
To begin with, let's place hi-hat notes at eighth note intervals. So we need to watch for whenever our tick value is evenly divisible by the eighth note value. So whenever tick modulus eighth note comes back as 0. So we can say if tick modulus eighth note is equal to 0, then we want to add a hi-hat note. So at this point, we can look into song and then look into the notes list and call the add method. Now, of course, add is going to need to take in a note instance. So here, in line with the method call, we will instantiate a new note. Now, this note is going to need to know what tick it exists at and what track it is placed on. Now, tick can simply be grabbed from the tick variable inside of our loop, and track is going to be set to 1, since that should match our configuration for the hi-hat track. Now, moving on from here, I'm going to copy these two lines and use similar if statements to assemble two more tracks. So we'll paste this in 2 additional times. And for the next track down, let's address the snare track. So as we're adding snares, we need to have those set to track 2. And the note distance, or the note spacing we're looking for, is half note spacing. So we'll drop in tick modulus half note. Now, in order to adjust the sound, adjust the rhythm that we're creating, we're also going to advance these notes or offset them by a quarter note. So before checking, we'll actually check tick as though it were advanced by a quarter note. And if that value is equal to a half note span, then we'll drop a snare note down on the track. Alright, finally we have the kick track. So we'll set the track to 6, and we will set up our kick notes every half note. So tick modulus half note without the offset that we're using for snare. So that way, again, snare and kick will occur at the same interval, but offset by a quarter note. Now that should take care of the creation of a song. So really, it's as simple as making a song instance and then adding information to that song.
Okay.
Now, the next thing to keep in mind is that nothing by default calls the reset method.
Mm-hmm.
We either have to have that method called from somewhere else in the game screen or call it from somewhere externally. So what we're going to do is make sure that as soon as the song selection screen invokes the game screen, we'll make sure that it calls reset. So that means over here inside of screen select, we're going to jump down to our input section. Then we have screen.pushScreen. So here's the line at which we actually invoke the game screen. Now as soon as we do, we're going to turn around and address screen.ActiveScreen, and we are going to tell the active screen to reset. Because as soon as we push the game screen, that means the game screen is now the active screen. So if we call ActiveScreen.reset, we will in turn be invoking this method, reset, which creates the song, sets up our note values, and stores notes into the song. So, once we have some note data, we need a way to look at it. So let's put together a temporary drawing routine. In the end, when we get our game complete, we will have a rendering engine system. Mm-hmm. So we'll have a framework in place so that note positions can be resolved and notes can be drawn on the screen with the appropriate supplemental information, things like a staff being drawn, a background, and so forth.
Sure.
But for now, since that gets into a bit more of a complicated topic, we will put together some simple drawing code directly into the game screen's draw method.
Okay, so it'll be kind of similar to what we were doing with the MusicEngine.
Actually, it'll be very similar. It will use the same kind of placement where we place notes horizontally by their tick value and vertically by their track value.
Okay.
Now, inside of game right now, we have a piece of debug text that's showing the number of players, and that is no longer needed. We already proved that our multiplayer state is being stored correctly, so we'll take those lines out all together. Now we need to put together a little bit of code to do some screen positioning, beginning with the center of the screen. We'll make a local variable called center, and we'll set that to be equal to half the width of the screen as it is rendered internally, which means we'll look into global state, we'll check the fixed drawing width, and we'll divide that by 2.
Okay.
Then once we have the center of the screen, we can go through all of our notes, note by note, and draw them to the screen. So we'll put together a for loop, and then bring up the template. We'll leave the index variable as I, and we'll loop for the total number of notes found within the song. So we'll look at song, look at notes, and grab its count. Now as we're looping note by note, we'll give ourselves a local variable just for convenience sake. So we'll make a note variable of type note, and we'll set that to be equal to song.notes sub I. And that simply saves us a little bit of typing every time we need to reference the current note.
Mm-hmm.
Now that we have the note, we can make a call to spritebatch.draw. So we will draw out, and we need a texture to draw with. Now if you remember back in the style class, matter of fact, if we take a quick trip back to game and load up style, you'll remember that we have some fields set up in the style class itself for some of the standard textures, one of those being a note texture. So we'll put that into play here. So we'll be drawing style.noteTexture. We need a position to draw this note at, looking here at the second overload of the spriteBatchDraw method, and we'll assemble a position based on the current note. So we'll make a new vector2. We need to specify an x component for that vector, and that x is going to be based on note.tick. Now, just like we did in the music demo, we want these notes to be centered on the center of the screen, so that the song's cursor matches the center of the screen. So what we'll do is we'll actually offset by center. So we'll start at the center of the screen, and then offset with the note tick. Now we need to specify the y component for our position, and to do that, we'll be looking at the note's track, but we need to multiply that by the height of each track. Now we haven't established a track height here, so we'll simply use the note's texture height. So we'll multiply this by style.noteTexture.height. And that takes care of our vector2. Now, once again, we seem to be running out of room here in the text editor. So what I'll do very briefly is I'll move this new vector2 out to a local variable right before the call to draw. So we can jump in here right under a note. We can make a vector2 variable called position and set that equal to a new vector2, which has all of our position information in it. That way our call to spritebatch.draw can simply be the note texture,
and then position,
and then for a color, we need to reference a color out of the track colors list. That means if we look back over in our config class, we had the set of fields called track names and track colors. Track colors should correspond to a specific track. So following what we did with the position variable, let's make a color variable called color and set that equal to config dot track colors, and then we need to reference by a specific track, and our tracks are stored inside of our notes. So we'll look at the current note and grab its track value.
Okay.
Now that we have color, we can plug that into our spriteBatch draw call as color. And that should take care of sprite-batch.draw. And that loop should take care of all of the notes that we have inside of the song. Now, one last thing to do is to visually indicate where our cursor is, where our song's cursor will be. So we'll draw a vertical strip across the screen at the screen center. So we'll make a second call to sprite-batch.draw. And this time we will be drawing just the fill texture. So we'll look into style.fill texture. And we need to fill a thin strip across the screen, so we will assemble a new rectangle to represent this area. The rectangle's X component will be the center of the screen. The Y component will be 0, so we start drawing at the top of the screen. The width will be set to match the width of any given note, and we're using the note's texture to specify that size. So we'll grab style.noteTexture.width, and for our Y component of our rectangle, we'll specify let's do something different from where we did in the music demo. Instead of spanning the entire screen, let's only span the number of tracks that we have. So we can actually take our note height, multiply that by the number of tracks, and that should give us the height of you could almost say the height of our staff at that point.
Right.
So once again, we can look at style, where we can grab our note texture. Our note texture has a height. So height would be the height of a single track. We could multiply that by the number of tracks. And in order to get the number of tracks, we would need to look into either our track names or track colors list. So if we look back in config, we have track names, and we can get the track names count, and that will give us the number of tracks. Now, once again, this has become a rather large definition of a type here for our rectangle. So I'm going to move the entire rectangle definition out
to a new variable,
and we'll place it inside of its own variable. So we can make a rectangle variable called, we could call this cursor or hit line. Just to spell it out, we'll do this. We'll call it rectangle cursor marker or indicator. I like cursor marker. And we'll set that to be this rectangle definition made out of a whole bunch of stuff. As a matter of fact, to make this one step further, isn't this fun playing around
start
with
using
space?
some white space.
We could drop each of the components down to their own line.
Sure.
And then we can more easily read out X, Y, and then width and height.
Okay.
And see where everything is coming from. So once we have all of that established, we can plug this into our draw call where we drop in cursor marker. And finally we're left with a color to use when drawing. And here we'll just make a new semi-transparent color. So we can make a new color, specify 255 for the red, green, and blue components, and then drop in 64 to give ourselves
some transparency.
Yeah, we'll drop in 64 for the alpha, and that'll make the whole line transparent.
Gotcha.
Now, with all of this put together, we should be ready to try things out. So let's hit F5, build and run the game, jump into single player, hit enter at the select screen, and look at that.
There we go.
We have this line drawn across the center of the screen, and we see a series of notes evenly spaced. You'll also note that there is spacing in between the tracks. You can actually see between the snare and hi-hat notes. We do have some spacing. And that was all placed in the design of the note graphic itself.
Okay.
Rather than deal with a bunch of additional spacing offsets, note by note, when we go to draw them, it was a lot easier just to take the graphic itself and define the spacing there.
Some 0 alpha pixels at the top and bottom?
Exactly.
Gotcha.
And since that note graphic's dimensions are taken into account when we draw, that means we can adjust the track spacing simply by adjusting the graphic.
Right.
And that greatly simplifies the code that we can use to draw.
Very nice.
So briefly, we could go up here and play around with measure count a little bit. We could up that to 2. And then see that then we now have enough measures to fill up the screen.
Gotcha. Now, at this time, we have no code in place to drive that forward.
That's right. If you remember, we're using the base song class. Song currently has no way to advance the song.
Right.
We could call tick all day long, but it's not linked up to anything, so we won't actually be advancing. So this was purely a demonstration of how to put the song into use, what kind of data we need to plug into the song if we wanted to start storing notes, and then what that data would look like if we drew it to the screen.
And that draw is all temporary code that would eventually be added into a rendering system when we create one.
That's right. But there's many more considerations than just the core note loop. So we're going to leave it simple inside of the class here. The whole point was to show, one, the usage of the song class, as well as the fact that it does greatly clean up the code when you're using a song. Where earlier in the music demo we had many different fields for our resolution settings, things like tick values. We had separate fields for individual tracks, whereas here everything is stored neatly into a single song class.
So it seems like from here we need to bridge the gap from storing some notes and showing some notes on the screen to actually playing something back.
Right. So here in the next video we'll be taking a look at putting a new kind of song into action.
Okay. Well, let's take a look at that in the next video.